second law of thermodynamics.
So let's go and learn! Second law of thermodynamics states that the net entropy of a system is always increases and never decreases. So what is entropy? Entropy is the measures of the disorder of randomness in a system. So it means that the energy tends to spread out and become more disordered over time.
This is why a hot cup of coffee left out in an open area eventually cools down as the heat energy is spread out in surrounding environment.
To understand the second law equations, we must first know the mathematical form of entropy. So when a system goes from one state to another, its entropy change is defined as the amount of heat exchanged divided by the temperature at which the exchange takes place. Therefore, the change of entropy for the system and the surroundings are given as follows. For the change of entropy in the system is equals to the amount of heat and the system is divided by the temperature. And for the change of entropy in the surroundings is equals to the amount of heat in the surroundings divided by the temperature. The total of the entropy change is the sum of the entropy changes and the surroundings and the system. So this total is the entropy change in the universe. There are two processes of second law of thermodynamics. First is the reversible process. For a reversible, isothermal process is the heat lost by the system is equals to the heat gained by the surroundings. Similarly, the heat gained by the system is equals to the heat lost by the surroundings. Therefore, the amount of heat in the system is equals to the negative amount of heat in the surroundings. Hence, the change entropy of the universe is equals to the amount of heat in the system divided by temperature minus the amount of heat in the system divided by temperature is equals to 0. The second process is the irreversible process. If the process is irreversible, then the heat absorbed by the system from the surroundings is given by the reversible amount of heat is equals to nRT in V2 divided by V1, where V1 is the initial volume of the system and V2 is the final volume of the system. And the T is the temperature of which volume change occurs. And the R is the universal gas constant and the N is the numbers of moles.
The second law of thermodynamics has two alternative statements. So these are Clausius statement and Kelvin-Planck statement. The first is the Clausius statement. So the Clausius statement, it is impossible to construct a device that auto-rating in a complete cycle produces no effect other than transferring heat from a cold body to hot body. So this is an application of the second law lies in heat engines and refrigerators. The second law places theoretical limits on the performance of these machines Kelvin-Planck statement. It implies that no heat engine can have a thermal efficiency of 100%. Otherwise, it would violate the second law. For example, a diesel engine has a thermal efficiency of 30%.
I am Jackie Lubantigi
And I am Liz Milan.
Hope you enjoy and learn. Thank you for watching.